So now the next is optical properties. What is meant by optical? Optical means when it can rotate the optically active. When we can say that when a molecule or anything, any compound, when it can rotate the plane polarized light, then we can say it as optically active. Optically active molecules are chiral molecules. It is written here is optically molecules are chiral molecules. Chiral molecules means a carbon having four uh, different groups. So what? Oh God. So what does it get? Suppose to take an example of this. It is having okay. This is glycine. So it is not a optically active compound because two hydrogens are attached to a single carbon. So we can say that it is a chiral, right? And it is symmetric. We can say that it is symmetric. The other way, like the two or more words we can use is first one is achiral, second one is symmetric, third one is impossible, super impossible. Mirror image can be formed here. Whereas in case of this alanine, four different compounds are attached to a single carbon. So we are calling it as chiral or asymmetric and non-super impossible images are formed. And we can even call them as enantiomers. 1 minute, I'll check it. Enantiomers is the non-super. So it is called as enantiomers. So take an example of aniline. Alanine. Okay, so except glycine, all compounds are chiral compounds. So in this, if the plane here we can see that if normal light is there when it is passed through a prism, it will because of this plane polarized light. When it then it is again this is a sample which is contains our compounds. So these compounds it can either exhibit L direction or it can exhibit D direction, like either left side or either like. Where is my pen? God. Whatever the sample is there when it is passed through a prism, so it can either go the this either go left side or it can go right side. So when it is going left side, we call it as levorotatory. L for left, L for levo. Remember it like that. So levorotatory, and next one is dextrorotatory. The other one, the one if the compound is a plane of polarized right, moves through the right side, then we call it as dextro. These are the two things you have to remember: levo and dextro. If it is anti-clockwise, then we call it as levo, and if it is clockwise, then we call it as dextrorotatory. And for dextrorotatory, we give this plus signature sign, and whereas for this levorotatory, it is designated as minus, respectively. Okay. So now the optical activity, how it is measured? It is measured by a polarimeter. Polarimeter, it is just like a hollow tube, like this. It is just like a hollow tube. Here it contains like. So here it contains all glass, and here also it contains glass. When it see through a naked eye, whatever the sample we keep, this by the visible, it is visible by our naked eye. No need to use of any this microscope and all. So this is nothing but a polarimeter. I know it is very bad diagram, but please bear it. So now the optical activity of a compound, we got to know that optical rotation. So that active the rotation we are calling it as optical rotation. So now we have to remember these five compounds, five things. One, what is the first important thing we have to know is that when you are passing a sample through polarimeter, we have to know what is the light we are using, or like up to what distance it can go. Second one is concentration of sample. It is measured in gram per ml, and this is measured in decimeter. And then this T and alpha, this wavelength lambda. T for temperature. Temperature, obviously we have to measure. We have to keep the standard temperature. Whereas lambda, like the amount of light the sample will be. It's like I'm moving my hand like this. So this is the amount of like I'm moving. See this. Yeah, you can see here like see my pen, how it is moving. Like when I'm passing my torch, light is passing through it. So this is nothing but wavelength. Can you see this, like, yes, dark color, uh, silver color. So it is nothing but wavelength. So I'm passing this amount of wavelength, visible wavelength to it. That's why it is showing this silver colored light. So that is the thing about wavelength. T is temperature, and yeah, this the question asked was this only. He that the examiner asked us to know the observed value in degrees. He just, I think he gave the glucose, and he gave some concentration of that glucose. So we have, so the thing we have to do is, wavelength we have to take 589 nanometer. For if the wavelength is not given, then we have to take 589 nanometer. Concentration, matlab if concentration is not given, we have to take 1 gram, 1 gram per ml. So now it depends ki glucose, it will give volume of glucose, and like if it gives 2 ml of glucose, so we have to take 2 grams of solution, so 2 by 2 as 2 gram per ml. So the same way, then the temperature that is 28 degrees centigrade as our normal room temperature. And then what else? Temperature, wavelength. Yeah, only two things we have to do, and the length. Yeah, the length. If it is not given, if the length has not been given, then we have to take only 1 decimeter, and we have to just multiply, and we will get the observed rotation in degrees. So now this specific rotation, what is it saying? What is specific rotation? Now specific rotation is nothing but the reference value of optical properties. Like whatever the optical rotation, optically rotation we got, so the reference value of this is nothing but specific rotation. So now specific rotation, like we are saying ki how much amount of concentration. If the concentration is not given, so what amount of concentration you have to consider? 1 gram per ml. If length is not given, what you have to consider? 1 decimeter. If the wavelength or temperature is not given, you have to take 589 nanometer, and temperature is 27 degrees centigrade. That's it. This was about the question was from this, and this polarimeter wala question, and it is quantitative measure. It says कि how much quantity, मतलब quantity, how much amount of moles of mm, compound is present, like that.